The next thing I want to demonstrate is an elevation oblique of our cylindrical form. And I'm going to do it in two ways. The first way, I'm going to point the circle at the picture plane. Okay, so we're going to be looking at it as if the ground was beneath and our cylinder is lying like this. Okay, next we'll also look at it in this direction, and so our elevation is going to look like a rectangle. All right, you'll be surprised, these are very different. All right, I've drawn two different elevations. One is the elevation of this item as if it were laying, let's pretend this is the ground here, laying on the ground. Okay. The other is the elevation as if it were sitting upright on the ground like this. All right. Next, we're going to project all of our important points and vertices back into the depth of the drawing. And remember that you can choose your angle, and I'm using a 45. Okay, so I've made my projections back into the plane of the drawing. Okay, this one's going to be pretty easy, so let's do it first. What we're going to do is draw the circle of the back part of the cylinder. Okay. So I will measure, let's see, what was it again? 2 3/4. Apparently I can never remember that. 2 3/4. Right here. And I'll use my compass again to finish that off. All right. This one's a little bit harder. So first let's measure that 2 3/4. Okay. And I'll transfer that around our box. But, uh-oh, that doesn't look anything like our cylinder. It turns out we're going to need to use that same diagonal circumscribing method that we used in the axonometric demonstration. So first thing you want to do is draw some diagonals on your box. Here's my center point. You're going to mark your halfway. I'm just doing it by eye. You can draw those if you like. Oops, that should be, there we go. And then on these diagonals, we want to divide them into thirds. Okay. So in this direction, our circle is going to turn into an ellipse, okay, because we are not in the plane of projection. We are perpendicular to the plane of projection. And so it will look something like this. All right. I can use the diagonal method down here at the bottom, or I can project these tangent points down. Okay. And let's see, I know I want to hit this point and this point. I can do this by eye. Okay. So there are two very different effects. Okay, so we have one where the curve is in the projection plane and one where the curve is perpendicular to the projection plane. Let's talk about foreshortening. If you take a look at this, it looks very long to me. And so our 50%, I'm measuring this by eye, is going to look something like this. sorry, that's our 75%, and our 50% is going to look like this. Okay. In the other direction, um, you can see it's very oval shaped and not the round shape that we know and love. When you foreshorten in perspective, you're getting an oval that goes the other direction. We're actually getting it stretched in this direction. So there's some distortion going on. So the foreshortening that you would do is in this length. Okay, and we could shorten that to, let's see, here's our 50%. We could shorten it to 75% right here, which would make our box quite a bit smaller. Sorry, my red pen's dying. Oh, there we go. Make our red. And I gotta switch red pens. Okay, I found another red one, so hopefully this works for you. So our box would be significantly smaller. Okay, because we're foreshortening it in this direction. Therefore, I'm just going to do this by eye here. We're going to get this type of oval. And our depth has been reduced by foreshortening that, this depth direction, not the vertical direction. That's for the plan oblique. In the elevation oblique, it's the depth direction. All right, everybody, I demonstrated to you a plan oblique and an elevation oblique of a simple box form, and then a couple different versions of curves. I hope this has really helped you with some of the step-by-step instructions, and you'll need to take these simple forms and use the additive or subtractive methods to come up with a more complex drawing. Thanks, everyone.